Now the next one again tells me to factor completely in the directions. The name of it is factoring with repeated use of difference of squares. So you'll see where that comes in, where I have the repeated use of the difference of squares formula. But again, it says factor completely, and whenever it says factor completely, there's my sign, take out the greatest common factor first. So in this case, I can divide both of those by 2, and they both also have a u squared. Can't take out any v's. So if I take the 2u squared out of there, 32u squared divided by 2u squared just leaves me a 16, minus 2u squared v to the fourth, going to leave me a minus v to the fourth. So what I have left in the parentheses is that difference of squares that we factored before, where we said, oh, it factors into conjugates. 16 is 4 times 4, v to the fourth would be v to the second times v to the second, and one has a plus and one has a minus. The 2u squared is going to go out in front. Now notice the directions, or the name said with the repeated use of difference of squares formula. We have the difference of squares here, but we have it a second time. We can't factor the sum of squares. If we tried to factor that, there has to be a middle term because we'd be adding the two middle terms together. So we can't factor the sum of squares, but we have to factor the different squares a second time. So factoring the 4 minus v squared. Factors of 4, 2 and 2. Factors of v squared, v and v. One has a plus, one has a minus. And so I have 2u squared times 4 plus v squared times 2 plus v times 2 minus v. And all of that has to go in for my answer. It's a big long answer to type in. So number 20, same thing. Tells me to factor completely. Whenever it says factor completely, I look for the greatest common factor. Both of these have a v to the third power. So I'm going to put the v to the third out in front. Leaves me a u to the fourth and a minus 16. Again, looks very similar to the previous one. They just have it switched around. You don't want to switch it. Leave it in the order it is and just go ahead and factor. So factoring the u to the fourth minus 16. U to the fourth is u squared and u squared. 16 is 4 and 4. One's going to have a plus and one's going to have a minus. And of course the v cubed is out in front. We know we're factoring with the repeated use of difference of squares. You can see again we have the difference of squared on the end, so I'm going to factor that. Factors of u squared, u and u. Factors of 4, 2 and 2. One has a plus and one has a minus. So we have v to the third times u squared plus 4 times u plus 2 times u minus 2. And all of that is going to go in for your answer. I'm going to try to sneak the next one in so I don't have to move the board. Looking at that one, my greatest common factor, they both have an x to the third. So I'm going to take the x cubed out, and what I have is 81 minus u to the fourth. And so factoring that, I'm going to go over here. The x to the third is out in front. Factoring the 81 minus u to the fourth. 81, 9 times 9, u to the fourth. U squared and u squared, we know one has a plus and one has a minus. So again, we know that we can factor a second time. We can only factor the one with the minus sign, the difference of squares. So I'm going to have the x to the third, I'm going to have the 9 plus u squared, and then I'm going to factor the 9 minus u squared. So 9 would be 3 times 3. U squared is a u and a u. We know one has to have a plus and one has to have a minus. So we have x to the third, 9 plus u squared, 3 plus u, and 3 minus u. So you won't see the name when you're on the assessment, factoring with the repeated use of difference of squares. You'll just see factor completely. Know whenever it says factor completely to do the greatest common factor first. And then hopefully you recognize you have the difference of squares and then the difference of squares a second time.